Module 1 in Mathematics 10. Let's have a review. What is a sequence? What is the difference between finite and infinite sequence? Now, let us have arithmetic sequences and series. Arithmetic sequence is a sequence where every term after the first is obtained by adding a constant number, called common difference, denoted by small letter d. To derive the general formula in finding the nth term of an arithmetic sequence, let us use the sequence 3, 7, 11, 15. The first number is 3. The next number is obtained by adding 4. 3 plus 4 is 7, 7 plus 4 is 11, and 11 plus 4 is 15. Thus, for the first number 3, we have 3 plus 0 times 4. For the second number 7, we have 3 plus 1 times 4. For the third number 11, we have 3 plus 2 times 4. And for the last number 15, we have 3 plus 3 times 4. Or in symbols, we have a sub 1 is equal to a sub 1 plus 0 times d. Or simply a sub 1. A sub 2 is equal to a sub 1 plus 1 times d. A sub 3 is equal to a sub 1 plus 2 times d. And a sub 4 is equal to a sub 1 plus 3 times d. Therefore, the general formula in finding the nth term of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. Using this formula, our a sub 1 refers to the first term. Our a sub n refers to the nth term or the last term. Our n refers to the number of terms or term number. And our d refers to the common difference. Let us observe the following sequences. Which of the following sequences are examples of arithmetic sequences? Is it letter A, 8, 13, 21, 34, and so on? Is it letter B, 4, 16, 64, 256? Or is it letter C, 9.3, 7.3, 5.3, 3.3, 1.3? Given these sequences, the arithmetic sequences will be letter A, 8, 13, 18, 23, and so on. Because they have the same difference or common difference, which is 5. 13 minus 8 is 5, 18 minus 13 is 5, and 23 minus 18 is 5. Another arithmetic sequence is letter C, 9.3, 7.3, 5.3, 3.3, 1.3. because the common difference is negative 2. 7.3 minus 9.3 is negative 2. 5.3 minus 7.3 is negative 2. 3.3 minus 5.3 is negative 2. And 1.3 minus 3.3 is negative 2. On the other hand, letter B is not an arithmetic sequence. Why? Because they do not have the same difference. As we subtract 16 by 4, that would give us 12. And 64 minus 16 is equal to 48. And 256 minus 64 is equal to 192. Let us have another example. Find the formula for the n term of an arithmetic sequence with a common difference of 2 and whose first term is negative 3. Our given will be a sub 1 equals negative 3 and the common difference, or d, is equal to 2. Knowing the formula, a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, we substitute the values. Our a sub 1 again is negative 3 and our d is equal to 2. Simplifying this, by distributing 2 to n minus 1, we will have a sub n is equal to negative 3 plus 2n minus 2. Using the right side of the equation, negative 3 minus 2 will be simplified as negative 5. Therefore, we have a sub n is equal to 2n minus 5. Therefore, the formula for the n term is a sub n equals 2n minus 5. Another example. The 15th term of an arithmetic sequence is 29, and the 27th term is 47. Find d, a sub 1, and the 5th term. So again, our given are a sub 15 is equal to 29 and a sub 27 is equal to 47. Since our a sub 1, our d are missing, we will now create equations. So we have a sub 15 is equal to a sub 1 plus 15 minus 1 times d. Simplifying 15 minus 1, that will give us 14. And our a sub 15 is equal to 29, therefore we have 29 is equal to a sub 1 plus 14d. This is now the first equation. For the second one, we have a sub 27 is equal to a sub 1 plus 27 minus 1 times d. Simplifying again 27 minus 1, that will give us 26. Our a sub 27 is 47 is equal to a sub 1 plus 26d. This is now the second equation. To solve for the value of an unknown variable, given 29 equals a sub 1 plus 14d and 47 equals a sub 1 plus 26d, we have to use the elimination method by addition or subtraction. So we will now subtract the two given equations. So 29 minus 47 is equal to negative 18, and our a sub 1 minus a sub 1 will be cancelled, and 14 minus 26 would be negative 12, and copy D. So we have negative 18 is equal to negative 12D. To get the value of D, we use multiplication property of equality, or MPE. We will multiply the whole equation by negative 1 over 12. So we can have D as equal to 3 halves. Using the first equation for a sub 15, that is a sub 15 is equal to a sub 1 plus 15 minus 1 times D, we substitute first the value again of a sub 15, which is 29. Then simplify 15 minus 1, that is 14, multiplied by D is 14D. Using the obtained value of D, which is 3 halves, by substitution we'll have 29 is equal to a sub 1 plus 14 times 3 halves. Simplifying this equation, we will have 29 is equal to a sub 1 plus 21. To find for a sub 1, we use addition property of equality to eliminate positive 21 on the right side. So we will add negative 21 both sides. Therefore, you will have a sub 1 is equal to 29 minus 21, which is equal to 8. Let us use the other equation. Using a sub 27, which is equal to a sub 1 plus 27 minus 1 times D. Our a sub 27 is 47, is equal to a sub 1 plus, simplifying 27 minus 1 will give us 26 times D, that becomes 26D. By substitution, our D is 3 halves again. So that is 47 is equal to a sub 1 plus 26 times 3 halves. Simplifying this one, you will have 47 is equal to a sub 1 plus 39. To get the value of a sub 1, we will use again addition property of equality, or APE. We will add negative 39 both sides to eliminate the positive 39 on the right side. So we have a sub 1 is equal to 47 minus 39, which is still equal to positive 8. Therefore, our a sub 1 is really equal to positive 8. To find the fifth term, we have a sub 5 is equal to a sub 1 plus the quantity of n minus 1 times D. Substituting the obtained values of a sub 1 and D, we'll have a sub 5 is equal to 8 plus 5, because we're looking for the fifth term, that would be our n, minus 1 times 3 halves. Following the PEMDAS rule, we subtract first 5 and 1, and then multiply it by 3 halves, then adding that to 8. So we have a sub 5 is equal to 8 plus 4 times 3 halves, or that would be equal to 14. Therefore, a sub 1, D, and fifth term are 8, 3 halves, and 14 respectively. Another example. In the sequence 0.07, 0.12, 0.17, and so on, what term has a value of 1.67? So our given are a sub 1, which is equal to 0.07, and our common difference is equal to 0.05. our a sub n is equal to 1.67. To find for our n, we use the formula n equals 1 plus a sub n minus a sub 1 over d. By substitution, we have n equals 1 plus our last term, or a sub n, 1.67, minus the first term, or a sub 1, 0.07, divided by our d, 0.05. Simplifying this first, 1.67 minus 0.07, then divided by 0.05, and then add it to 1. So we have n equals 1 plus 32. Our n is now equal to 33. Therefore, 1.67 will be the 33rd term. Arithmetic means. Arithmetic means are terms m sub 1, m sub 2, m sub 3, until m sub k between two numbers a and b such that a sub 1, m sub 1, m sub 2, until m sub k, where b is an arithmetic sequence. Let's have this example. Complete the arithmetic sequence. We have two numbers before 1/2 and two numbers after 1/2, and the last term is 2. So we have 6 numbers. So since the third term and the sixth number are given, we have a sub 3 is equal to 1/2 and a sub 6 is equal to 2. Let's find first our d, or the common difference. Using the formula, d equals a sub n minus a sub k over k minus 1. So we have here 2 minus 1/2 over 4 minus 1. And our d is now equal to 1/2. To complete the arithmetic sequence, let us use d as equal to 1/2. So we have negative 1/2, 0, 1/2, 1, 3 over 2, and 2. Therefore, the sequence is negative 1/2, 0, 1/2, 1, 3 over 2, and 2. What about arithmetic series? Arithmetic series is the indicated sum of the terms of an arithmetic sequence. To derive the formula of arithmetic series, we have S sub n referring to the sum is equal to a sub 1 plus a sub 2 plus a sub 3 plus until a sub n. So we have S sub n is equal to a sub 1 plus a sub 1 plus d. This a sub 1 plus d will refer to a sub 2 plus a sub 1 plus 2d will refer to the a sub 3 until a sub n. So this will be the first equation. Rewriting the expanded form in the reverse order with decreasing d, we will have S sub n is equal to a sub n plus the quantity of a sub n minus d plus the quantity of a sub n minus 2d plus until a sub 1. So we just take the reverse order. This will now be the second equation. Adding the first and the second term by term, we have S sub n is equal to a sub 1 plus a sub 1 plus d plus a sub 1 plus 2d until a sub n. The second equation is S sub n is equal to a sub n plus the quantity of a sub n minus d plus the quantity of a sub n minus 2d plus until the a sub 1. So we have S sub n plus S sub n is equal to 2S sub n. A sub 1 plus A sub n is equal to A sub 1 plus A sub n. And then A sub 1 plus D plus A sub n minus D will cancel this D because they have different signs. So we will have A sub 1 plus A sub n. The same thing with A sub 1 plus 2D plus A sub n minus 2D. They have different signs, positive and negative, so they must be cancelled. We'll have A sub 1 plus A sub n. Plus the remaining terms A sub n plus A sub 1 or A sub 1 plus A sub n. So as you have noticed, we have repeating terms here. We have A sub 1 plus A sub n. So we can simplify this as 2S sub n is equal to n times A sub 1 plus A sub n. And then we have to apply again our multiplication property of equality to eliminate 2 besides S sub n. We'll multiply 1/2 both sides of the equation. So you have S sub n is equal to n over 2 times A sub 1 plus A sub n. So this formula will be used if the given are the first term and the last term. Using this obtained formula, S sub n is equal to n over 2 times A sub 1 plus A sub n. To take another formula in finding the sum of the terms given arithmetic sequence, substitute A sub 1 plus n minus 1 times d into A sub n. So we have S sub n is equal to n over 2 times 2A sub 1 plus n minus 1 times d. This is another formula in finding the arithmetic series, wherein the first term, the number of terms, and d are given. Example: find the sum of integers between 50 and 150 which are divisible by 5. So our first term is 50. Since divisible by 5, that would be your common difference. Our A sub n as the last term is 150. Finding n, we use again the formula n equals 1 plus A sub n minus A sub 1 over d. By substitution, we have 1 plus 150 minus 50 divided by 5. 150 minus 50 is 100 divided by 5 is 20. Adding these two numbers will get 21. So our n is equal to 21. So we have A sub 1 is equal to 50. Our A sub n is equal to 150. And n now is equal to 21. Solving for S sub 21, that would give us, first, we can use S sub n is equal to n over 2 times A sub 1 plus A sub n. By substitution, our n is equal to 21. Our a sub 1 is 50 and the a sub n is 150. So we have s of 21 is equal to 21 over 2 times 50 plus 150. Simplifying this, we can get s of 21 is equal to 2,100. Therefore, the sum of integers between 50 and 150, which are divisible by 5, is 2,100. Try this. Make a concept map for arithmetic sequences. Using the formula for arithmetic sequence, give problems where the unknown value is letter A sub 1, letter B, A sub n, letter C, D, and letter D, n. Show how each can be found.